And we're back. 8th grade, week 15, and we're talking not about sound and how we hear. We're going to change gears a little bit. We're going to be talking about electromagnetic waves. By the end of this lesson, you should be able to give a brief overview of electromagnetic waves. This is just an introduction. So you're not going to know everything after this lesson, okay? But here's a question for you. Did you ever wonder how a microwave works? Well, it directs invisible waves of radiation toward the food placed inside of it. The radiation transfers energy to the food, causing it to get warmer. The radiation is in the form of microwaves, which are a type of electromagnetic waves. So what are electromagnetic waves? Electromagnetic waves are waves that consist of vibrating electric and magnetic fields. Like other waves, electromagnetic waves transfer energy from one place to another. The transfer of energy by electromagnetic waves is called electromagnetic radiation. Electromagnetic waves can transfer energy through matter or across empty space. We're going to watch a quick video clip and learn a little bit more about the waves that are all around us, including microwaves, but electromagnetic waves in general.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected, and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green. Our eyes see the leaf as green, but cannot tell us anything about how the leaf reflects ultraviolet, microwave, or infrared waves. To learn more about the world around us, scientists and engineers have devised ways to enable us to see beyond that sliver of the EM spectrum called visible light. Data from multiple wavelengths help scientists study all kinds of amazing phenomena on Earth, from seasonal change to specific habitats. Everything around us emits, reflects, and absorbs EM radiation differently based on its composition. A graph showing these interactions across a region of the EM spectrum is called a spectral signature. Characteristic patterns, like fingerprints within the spectra, allow astronomers to identify an object's chemical composition and to determine such physical properties as temperature and density. NASA's Spitzer Space Telescope observed the presence of water and organic molecules in a galaxy 3.2 billion light-years away. Viewing our sun in multiple wavelengths with the SOHO satellite allows scientists to study and understand sunspots that are associated with solar flares and eruptions harmful to satellites, astronauts, and communications here on Earth. We are constantly learning more about our world and universe by taking advantage of the unique information contained in the different waves across the EM spectrum.
So, how do microwaves transfer energy inside the microwave oven? They transfer energy through the air inside the oven to the food. A familiar example may help you understand the vibrating electrical and magnetic fields that make up electromagnetic waves. Consider a bar magnet, like the one here. The bar magnet exerts magnetic force over an area all around it. This area is called a magnetic field. The field lines in the diagram represent the direction and location of the magnetic force. Because of the field surrounding the magnet, it can exert force on objects without touching them. They just have to be within its magnetic field. How would you demonstrate that a magnet can exert force on objects without touching them? Of course, that's right. You could put small objects that contain iron, such as paper clips, near a magnet and show that they move towards the magnet. An electric field is similar to a magnetic field. It is an area of electrical force surrounding a positively or negatively charged particle. You can see electric fields in this picture. Like a magnetic field, an electric field can exert force on objects over a distance without actually touching them. An electromagnetic wave begins when an electrically charged particle vibrates. Here we see how this happens. A vibrating charged particle, seen in the top left-hand corner of your screen, causes the electric field surrounding it to vibrate as well. The vibrating electric field, in turn, creates a vibrating magnetic field. The two types of vibrating fields combine to create an electromagnetic wave. As you can see here, the electromagnetic fields that make up an electromagnet are perpendicular or at right angles to each other. Both fields are also perpendicular to the direction that the wave travels. Therefore, an electromagnetic wave is a transverse wave. However, unlike mechanical transverse waves, which can only travel through matter, an electromagnetic transverse wave can travel through empty space. When waves travel through matter, they lose some energy to the matter as they pass through it. But when waves travel through space, no energy is lost. Therefore, electromagnetic waves don't get weaker as they travel. However, the energy is diluted as it travels farther from the source because it spreads out over an ever larger area. When electromagnetic waves strike matter, they may interact with it in the same ways that mechanical waves interact with matter. Electromagnetic waves may reflect or bounce back from a surface, refract or bend when entering a new medium, and diffract or spread out around and about various obstacles. Electromagnetic waves may also be absorbed by matter and converted into other forms of energy. Microwaves are a familiar example. When microwaves strike food in a microwave oven, they are absorbed and converted to thermal energy, which heats the food. The most important source of electromagnetic waves on Earth is the sun. Electromagnetic waves travel from the sun to Earth across space and provide virtually all the energy that supports life on our planet. Many other sources of electromagnetic waves depend on technology. For example, radio waves, microwaves, and X-rays. We use these electromagnetic waves for communications, cooking, medicine, and many other purposes. So, in summary, electromagnetic waves are waves that consist of vibrating electric and magnetic fields. They transfer energy through matter or across space. The transfer of energy by electromagnetic waves is called electromagnetic radiation. The electric and magnetic fields of an electromagnetic wave are areas of electric and magnetic force. The fields can exert force over objects at a distance. An electromagnetic wave begins when an electrically charged particle vibrates. This causes a vibrating electrical field, which in turn creates a vibrating magnetic field. The two vibrating fields together form an electromagnetic wave. An electromagnetic wave is a transverse wave that can travel across space as well as through matter. When it travels through space, it doesn't lose energy to a medium such as mechanical waves do. When electromagnetic waves strike matter, they may be reflected, refracted, or diffracted. Or they may be absorbed by matter and converted into other forms of energy. The most important source of electromagnetic waves on Earth is the sun. Many other sources of electromagnetic waves depend on technology. So, you should be able to give a brief overview of electromagnetic waves at this time. If not, feel free to go back to the videos. Otherwise, we do have a few questions for you. So move on to the next question. Have a great day, and we'll talk to you later. Bye now.